All right. Continuing track one of the AnyLogic Conference EMEA presentations. Welcome to those of you just joining us. I'm very happy to be introducing Andrei Slusarenko, who is from TBS Consulting, and he will be presenting today on how to increase the performance of a steel service center. Welcome, Andrei.
Thank you very much. Good morning, ladies and gentlemen. My name is Andrei Slusarenko. I am from TBS Consulting, Moscow, Russia, and I will tell you about a very interesting project that we performed last and this year. The contents will cover the prerequisites of project, why we used AnyLogic. We'll see a short demonstration, then deeper in some simulation specific for AnyLogic, and of course about lessons learned and questions and answers. First of all, a few words about our company. We are a small company focused on management and logistics consulting. We are AnyLogic partner for about 8 years, and we have developed over 30 simulation models, both within AnyLogic and AnyLogistics. And among our clients from different industries, there are some well-known brands as Microsoft, PepsiCo, and Toshiba, to name a few. Now, what is the scene? What is Steel Service Center for? You may know that contemporary industries, first of all, automotive, construction, manufacturing, generate a huge demand for steel strips or steel sheets. The producer usually procures these steel strips in the form of steel coil, that is, means steel tape rolled up in a coil. Such coil can have up to 2 meters of diameter and has a weight of more than 20 tons. The customers, of course, don't need such big quantities. They need particular sizes of these sheets for their processing needs. So that's the point when the Steel Service Center comes in. It provides specialized cutting of these incoming coils into sizes that are needed by the customers. You can cut the steel coil in two ways. First of all, you can make slitting and perform several coils of lesser widths. And these coils can have a horizontal or vertical orientation for storage and transportation. And the second way, you can unroll these coils. Just imagine that it has a very huge potential energy and is rather dangerous because it can unroll simultaneously. And so you cut to length and create a packs of steel sheets that can be the length of 6 meters length. And this is shipped to the end customers. So the Steel Service Center in question is located at small town of Monash in Belgium and provides a range of these cutting services for strip business of NLMK Europe. The production capacity is over 200,000 tons per year. That means about more than 10,000 coils. And what was the question? The plant management decided to increase the plant productivity. They have an ambitious target of increasing the productivity by about 1.5 times and consider installing a new production line. Just imagine that have rather big dimensions. And of course, there were several options to consider with different layouts. For example, how many production lines should we have? Where to place precisely this production line? What new equipment should we add, such as new cranes, conveyors, additional gates, and so on? Many interrelated factors. So the project goals was first to help the plant management to select the best option And the second, make stress test and evaluate the maximum possible plant performance. How many kilotons of slits and sheets per year the plant can produce in new conditions. The result of project was the first detailed technical specification. Then we built a more simulation model with AnyLogic for as-is configuration, and this was used for model verification. Then 5 simulation models with for different equipment layouts to test and to select the best one from them. What were the main project challenges? You see, the plant is located in a living area in a small town, and its territory is bounded by railway, canal, private property, so it's not much extra space to feed the new production line. Secondly, the place where the client trucks arriving for finished goods is rather limited, and it's complicated question how to avoid traffic jams, obstacles, taking into account that the number of trucks per day will increase in correspondence with increasing performance. Again, one should take into account, for example, seasonal variations in client demand or intraday variations for incoming and outgoing truck in the morning, afternoon, and then the evening. And we need to find the best solution that should fit all such constraints. We must take into account that most of these above-mentioned factors are significantly non-linear. Most of them are interdependent, but what's worse, a lot of them are controversial. By the way, to install a new production line in addition to existing ones, that means that we significantly decrease the possible space for storage of finished goods and so on. The second major point was that it's a running business, and of course we can't interrupt this running business to test installing a new crane or changing somehow in procedures. So simulation modeling is an optimal tool because the calculations in Excel usually are made only by average values, and they cannot take into account all these time-space collisions. So when we come to simulation model, then AnyLogic is definitely one of the leaders of this market, and it has definite advantages. First of all, it allows to combine different approaches to modeling, such as discrete event and agent one. We can use some ready off-the-box elements, such as multi-bridge cranes, transporters, or conveyors. Where you have indeed made a significant program development in Java to enhance the standard logic. And last but not the least, that we can the model in iterative way, and the customer can add more and more details to dig deeper into production specific. How the project was implemented. There was a first phase during which we have developed the detailed technical specification. It's a very important document because it fixes all model inputs, model outputs, used statistical distribution, requirements to the model, and so on. Then, after that, we did development of as-is model. The idea was to use historical data to prove that the model design, model architecture, and realization of model elements is up to date, and the model can provide us with data close to that of the historical ones. Then we did roll out one option after one, and the customer can adapt their requirements, yes, to check to check different options, different ideas, how to place the equipment to reach maximum performance. The key elements of the model, of course, includes business objects such as steel coils that can have two types of orientation. It's important to see in 3D stacks of steel sheets. Of course, trucks, cranes, forklifts, conveyors, transporters, production line. We do not model the very process of cutting the coil. Yes, it has a physical level of modeling, but nevertheless, the model logic includes uploading of the raw coil into production line, and after that the distribution of produced goods into different storage areas, as well as model of operators and also control system for trucks value. The model can cover all production cycles from arriving calls to production and so on. Regarding model inputs and outputs, the input data can be divided into two parts. The first part is so-called static data, and they depend only on the configurations such as number of production line, topology of coils, passes for trucks, and so on and so on. Then, of course, we need some initial stock values for input coils, for slits and sheets as well. Then we need historical data of arrival shipping, but this data were not used directly. Instead of all, we created a historical statistic just to be able to generate values for to-be options. That means the distributions of coil size, weight, different type of coating used in production. Also, the statistical distribution of flows for between day of week, hour of day, and seasonal values of work. Then we have the work shift schedule. We can change the timetable, the number of shifts or work shifts per week to achieve maximum performance. And in the iterative mode, the customer can set up the simulation period, desired shipped weight for slits and sheets separately, some extra parameters, and launch the model. So the model, the AnyLogic can store detailed data on each and every operation, the crane movement, forklift, operator movement, truck arrival, truck departure, and so on. This data are stored in the AnyLogic internal database. After that, they are exported to Excel and be subject to analyze to find the best decision. Now, as a picture is worth 1,000 words, let's have a look. Just a moment. The model has a multi-language interface, so we can switch on the fly from English to French, for example. Then we see the standard two-dimensional view just to take a view from its bird eye. Then a 3D set of three-dimensional preset views. Also, you can move the camera. And here we use artificial colors for incoming coil storage. These colors denotes coil size and type of material and the production line that it will be processed on which. You see this green circle and gray rectangles, that's the production line without internal details. Here are the different storage areas. You can see that the coil stored can be stored either with horizontal axis as here or as vertical axis and the top right corner. Here are different storage areas with sheets. Again, artificial color scheme to distinguish between sheets of different sizes, different type of material. We see that's client trucks that arrive to be loaded, and the customer has a preset of pre-assembly of orders during the night to speed up the truck loading process. The model also covers the external parking, the logic of truck being weighted before and after entering the site. And I would say that 3D models was of great help because it allows to find out some maybe possible errors or discrepancies in programming that are not visible on 2D map. That's some examples of what the model output data can be, different plots that the user can use to understand. A part of model logic. It's rather complicated because each production line does have its own logic, about several tens of any logic flowchart blocks. And so that was a short demo. We did different types of experiments, simulation standard run, parameter variation experiment, which allowed us to vary different static parameters to find the best value, fast run without user interface for long runs, and two types of experiments that were designated as long runs for 1 year because it allows to consider significant seasonal variations in supply and demand, and also short run, usually for 1 month, to examine in detail different options for movement, for equipment movement, for processing, and so on. And for 5 cases, which are different with different location and number of production lines, we investigated the effect of using different number of cranes, multi-bridge cranes, so single bridge, several number of scales, varying number of unloading gates, different shipping ratio, advantages of installation of the conveyor instead of forklifts and cranes, and many other things. A couple of things regarding AnyLogic internals that may be of interest. The first of all was the combination of agent and discrete event simulation for input cranes. The specific of the plant is that the single operator controls the crane as well as perform necessary manual operations. He controls the crane with such a specific device, portable device. And he must follow the crane when it goes in the facility. But as the crane can go straight forward because it loads high the coil, yes, the operator must follow the designated path due to necessary safety rules. And that was done by combining AnyLogic standard multi-bridge crane functionality and also state diagram for operator who monitors the bridge position and decides when it is time to go inside the row to perform the necessary coils. The second one is an interesting task for optimization of best location to store the incoming coil or just the finished goods, because the plant uses the storage in several layers. And when you need to take something from the bottom layer, you need to make unnecessary reshuffling operations. The idea is to decrease the number of these reshuffling operations as much as possible. And to this, we use the rule and strategy system. The rule applies to objects in different states and is bound to some logical storage zone, while the strategy implements the idea of trying to put the new sheet to the pack where the similar sheets are placed already on, just maybe to put it onto the top of existing stack and so on. And we can have different strategies. And for each possible cell, we just calculated the weight score and determine what's the best place to decrease both the time of putting the object into the store and taking it back later. So it allows to distinguish between business rules and Coda, so that the customer can fine-tune it independently. Some examples of performance indicators, what the model allows to understand different types of distributions for trucks, for equipment, for cranes. The model was extensively used to find out the bottlenecks during the execution. And for example, we can understand that one of the cranes will have high average utilization and peak utilization during some hours of the day. So we need to plan carefully the arrival procedure. Or we can note that there is a rare but long tail in the distribution. That's the time that incoming trucks spent in the arriving queue. And this may be of great importance again to plan arrival of coils, because the trucks are in limited number and they will not be able just to make the daily procurement in time. So some business decisions should be taken into account. Summing up the project results, simulation model already helped the management team to select the best option, and we confirm its maximum productivity. This simulation also allowed the project management to exclude some unnecessary equipment, to exclude some excessive costs from the project budget. If they install the new production line, it will significantly improve the ecological situation in the town, because it's much better. And now the customer also plans, besides this strategic implementation, also plans to use this model for everyday operations, to fine-tune the planning plots, or test, look for optimal strategies to store the goods. So that's all. Thank you very much for attention. Ready to answer questions if possible.
Thank you, Andrei. Very interesting, very detailed. I was just wondering about you said there would be ecological improvements from implementing the new production line. Did you have to implement anything extra into the model to be able to understand what those would be?
No, unfortunately, no, because it was just knowledge that the new line will be better than others. So the idea was to put the optimal location and prove that we can change one old line, which was not ecologically safe, I would say, as new one. We can substitute with the new one and still reach the necessary performance.
Okay, and looking back to the performance indicators, there were two that were highlighted. I think it was long run, the year, and the short run. What would be the differences in running those experiments?
When we when we perform the long run, yes, we can omit some details that may be interested, just to show about what are the distance that the operator, for example, Karen, take into account all turns that he is. But for long run, we can just make more more raw implementation, yes, just to use some average values for this to speed up the model, yes, to not show it every pace of this operator, for example, yes, because I focused only on seasonal trends to check if the model can make the performance in these conditions.
Super. I'm just looking through the questions here, and we've got one. How did you experiment with different locations of warehousing and operating areas? Did you use several layouts to experiment with?
We have several layouts. The locations of this production model, of this production line inside the building, but as the building has a preset of several halls, the selection of one of the halls affects seriously all the transportation routes inside the building. Just feeding and also extracting finished goods. So it's significantly interrelated with all other movements at the plant. Yes.
So the layout really constrains.
Layout, yes, topology, routes of cranes, forklifts, and so on.
And how easy would it be for the contractor to experiment with perhaps using different layouts if they're bringing in a new production line?
No, it was just separate models based, of course, on one logic. One as this model as a starting point. Yes, we take 5, then we move, and unfortunately, it requires some manual adjustment of all the passes and some adjustment of project logic, so on.
You're able to reuse some of the components.
Yeah, of course. Yeah, if it was maybe 80% reused, of course, it's not quite different models. Yes, but it requires some manual changes, not only the change of figures.
And which the libraries within AnyLogic do you use the most of? The material handling seems like
process and material handling. From material handling, we used this multi-bridge cranes, transporters, of course.
And what do you have any future plans that are looking to be added or implemented using the model?
No, as I have already said, the customer is now, after they have made a strategic decision to select the best operational well, they consider using this model for operational practice. Yes, because just we can knowing the plan, the demand for forthcoming several days, we can optimize the production plan, just not to overload the equipment. Or we can somewhat adjust the arrival plan for steel coils. So.
Great. Well, thank you very much, Andrei. I believe we've got a couple of minutes before we begin the next presentation.
Thank you. Bye.
Thank you. Goodbye.